Hey folks, let's continue our crash course on matrices and determinants. In this byte, we'll be checking out what are the simple matrix algebra. Precisely, we'll be talking about addition and subtraction and one more concept of scaling the matrix or multiplying the matrix by a scalar number. Just a quick word of caution. Matrix algebra can be done only if the order of the matrices are same. Pretty much what it means is it should be the rows and columns on both the matrices. For example, if you are having two matrices like I showed you here, for example, let's take the example. I'm going to add matrix 1 on the left to the matrix 2 on the right. The rows and the column or the order of the matrix on this matrix is 2 rows and 2 columns, and matrix 2 also is 2 rows and 2 columns. So addition and subtraction are possible only if the matrices are involved in the addition have the same order, meaning the number of rows and column in each matrix should match the other one. And in terms of the addition itself, it's just a simple numeric algebraic addition, but we'll be just adding the respective elements. For example, you will take this first row and first element here, and you will add to the first row and first element on this one. So 10 minus 6 is 4. Similarly, you will take the second row and first column and you will add it here. So since we know, if you remember, we saw that positional part where each number is assigned the rows and columns. So basically you'll match them on each one of them. If you're picking up element A11, which is first row, first column, you'll pick up the same element A11 on this and add, and so on and so forth. Nothing crazy. If you see an example here, I put it, we have got two matrices and the orders are again, it's a square matrix. And it doesn't have to be a square matrix, but in this case, it's a square matrix. But the rows and columns in each of them should match. For example, we could have very well had a rectangular matrix in both of them, and both of them could have had the same rows and columns, and still addition is possible. So it's nothing to do with the square or rectangular matrix. It's just the rows and columns in each matrix involved in the operation should have the same number of rows and columns or same number of elements within the row and within the column. And subtraction again is the same logic like addition, where you take respective elements. If you see this, we have color coded. So whatever is purple will go with purple, you subtract that. Whatever will go with maroon, it's maroon here, and then green, and then blue. You'll do that. And like normal number systems, when we add two matrices, A and B, and if we talk about addition, we can always flip the sequence. It's same as B plus A. Whereas in case of subtraction, for example, 2 minus 5 is not equal to 5 minus 2. Similarly, if you subtract two matrix A minus B, that is not going to be equal to B minus A. That's the only catch here. But otherwise, it's a simple algebraic operation of the respective positional elements to each one. Matrix is a positional play. The position of the element, which row and which column it appears, matters a lot. So the respective position should be added or subtracted. That's as simple as that. Now, slightly moving ahead on another concept called as a scalar multiplication. Okay. What is scalar multiplication? Let's say you in simple algebra numbers, let's say you have 5, and let's say you multiply this number by 2. So what it's going to do is this number is going to just double this number. The answer is going to be 10. So this number on the left, in essence, is going to scale, or vice versa. You can assume that this number is going to repeat it that many times on 2. You can think however you want, but for sake of simplicity, assume that this number on the left is going to double whatever number is here. For example, if I say 4 into 3, that's going to be 12. That means this number, which acts as a scalar, that's going to add 4 times to give the multiplication effect of 12. That's what it means. So over here, if you see the constant or the number outside the square brackets of matrix is called a scalar because it scales up or scales down. For example, I could have used over here, if you see, the scalar is number 2. This is a scalar. And it just multiplies each element twice. For example, if you have 4, you have 8. And then again, we just do for the respective positions for each of the elements. But let's say instead of 2, if you had minus 2, then each one would have a different algebraic sign because it's minus. So it can scale up being positive, or it can scale down being negative. So it does not really matter. And like just any other multiplication in terms of scalar, okay, when you're multiplying a matrix by just a scalar number, even if you put the number first or the matrix first, does not matter. For example, 2 into 5 is same as 5 into 2. In terms of scalar multiplication, the same concept applies. You can say k into the matrix, which will be same as matrix into k. So this particular thing applies, so it does not really change. Just in case of the scalar multiplication, meaning you're multiplying the matrix using a scalar. But when you multiply two matrices itself, which is different on this, you're multiplying two matrices, the order matches, or order, sorry, matters, which you will see in the next episode. For this episode, just addition, subtraction, and a scalar multiplication, meaning multiplying a matrix just by a number. What does it mean? And that's pretty straightforward. I'll see you in the next byte on the next topic.